Good day everyone. If you clicked and you're watching this video, thank you so much for the view. This is just going to be a tutorial video on physical and chemical change, targeted at grade 10 learners who are doing physical sciences CAPS. If you're from South Africa, you'll know what I mean when I talk about CAPS. Haven't actually looked at the IEB curriculum, but then I think it will also be beneficial try to talk about what is physical and what is chemical change and differentiate between the two. So let's just get started. Um, so I think one of the first things that we have to do is to describe or differentiate between two types of changes that take place in matter. So remember, matter can be, I'm trying to find this, okay. So matter can be anything that has a mass and occupies space. So a shoe can be matter, a person can be matter, a car, anything essentially. So we'll talk about some of the two changes that take place. So we have physical change and we also have chemical change. Chemical change is described as a change that you can see or feel. However, it does not involve the breakup of the particles in the reaction. So there's no new substance or compound or molecule that is formed during a chemical change, a physical change that is. Look at the example, the first example there. So when you take water and you heat it, let's say you boiling water, so it starts off in liquid form, right? And then because you're heating it, it has reached its boiling point. It's going to now evaporate. It's going to form steam. It's still the same water molecule that we started with, your H2O, and in the end, after heating it, it's still H2O. The only difference is in the state. First you started off with a liquid, hence that L in parentheses or in a bracket, and then now because it has evaporated, it's a gas. It's a gas, when you form steam. Let us now describe chemical change. So a chemical change is defined when by the formation of a new substance in a chemical reaction. So during a chemical reaction, one type of matter is changed into something different. Take an example of a chemical change. We talk about decomposition, which essentially means that normally you start off with a compound, and that compound is broken up into smaller molecules or compounds or even just elements. So here we have a formula, a chemical here, H2O2. This is hydrogen peroxide. Don't worry now about the this what is this coefficient. It's just in terms I've balanced it. In the next video we're actually gonna learn of how do we actually balance chemical um equations. So here we have hydrogen peroxide, which is H2O2, that is breaking apart. So this is before the reaction takes place, then something occurs, it breaks into H2O, that's water, as well as your oxygen molecule, right? So you started off with something and you ending up with something else. Then we know that a new substance has formed. One type of matter was changed into something else. So that is how we essentially differentiate between physical change and chemical change. Now let us look at other examples of physical change. So when you melt a candle, for example, you heating it, let's say you heat a candle, then it starts to melt. It doesn't mean that the wax has now changed into something else. It's just that it's just melted. So that's an example of a physical change. You have seen it, or maybe you've even felt it because you feel the temperature increase, right? Now if you tear a piece of magnesium strip, so magnesium strip is just shiny, I don't want to say silverish material. When you burn a magnesium strip, I think it produces this white light, if I'm not mistaken. You can just Google that. So when you tear it apart, think about tearing anything apart. You're not actually changing the composition. You're not changing what it is. It's still magnesium strip. The only thing that is changing is the form of it, right? Even the same when you dissolve sugar into water. the glucose, the glucose molecules, they remain intact. They don't dissociate in any way, they don't decompose in any way. But now I have a question for you. What do you think happens? Do you think when you dissolve salt into water, is that an example of a physical change or a chemical change? Think about it. There's a very interesting debate or confusion whether when you dissolve sugar into water, is it physical or chemical? Now let's look at more example of chemical change, right? I've spoken about decomposition where you start off with a larger compound and it's broken up into a smaller compounds or a molecule, right? So you started off with hydrogen peroxide, then you ending up with water and oxygen. There's also the reverse of that when we call synthesis reaction. So you're starting off with smaller molecules or elements and they combine to form a larger compound. So you're creating something. So it's the creation. This one is the breaking apart of something. So you started off with this and you end up with this. So it's an example of your chemical change. So you started off with hydrogen, you added it to with oxygen, and then you get your water. Another example that we'll talk about later in this presentation is rusting. So you've seen that most steel thing, if you look at steel and you put it outside into the air, and it rusts and then it forms that brownish layer on top. And that is an example of a chemical change because the iron will actually oxidize and react with the oxygen to form iron oxide. So you started off with iron, and then it oxidized in the air to form iron oxide. So it rusts and it creates that brown layer that I'm referring to that you often observe in steel, even when something rots. So if you've put something in, let's say in your fridge for 10 weeks, or maybe you get load shedding and then when it comes back it's spoiled, it's rotten. You started off with one type of matter and then it changed into something else, right? I hope that is clear. If we move on right along, so these are just some important things to take note of when we talk about physical and chemical change, right? So physical change, for example, it's usually very easy to reverse. Usually, we being the keyword doesn't mean all the time you can reverse it. If you look at our example there with water, wait, how do I go back? Okay, this thing doesn't want to go back, it's fine. So if you look at an example of water, you can boil, you can, let's say you take liquid, you freeze it, you put it in the fridge, in the deep freeze, and then it's from liquid it becomes ice, so it's now a solid. You can reverse that same reaction by just heating the ice or putting it outside of the fridge and then it starts to melt. However, chemical change, they're saying that it's usually a bit more difficult to reverse. It doesn't mean it doesn't happen. Some reactions, some chemical reactions are actually quite reversible, right? Another thing with physical change, so the important thing is that there's no new substance that is formed during a physical change. You start with water, you end up with water just in a different form. Take note of that. However, in a chemical change, you start with one thing, you start with hydrogen peroxide, and then you end up with water and oxygen. During physical changes, they mentioning that it involves small energy changes. However, with chemical change, a lot of energy is involved, to break a molecule apart or to synthesize a molecule, to either decompose or synthesize. There's a lot of energy that is involved in these types of reaction. And now just looking at more examples. So physical change, an example of physical change, we spoke about the melting of candle wax. Another example that we've spoken about is when you boil your water and it forms that steam, and we say that is evaporation, right? Even when we separate mixtures, so you can mix sand with something and it doesn't mean that the sand is going to change it to something, right? And then examples of chemical change that you can look up, we've spoken about decomposition, which is the breaking apart of a larger compound into smaller compounds or elements or even molecules, right? Synthesis, you start with smaller compounds, small elements, and then they combine to form a larger molecule. When you burn something, that's an example of a chemical change. When something rots, maybe in your fridge, that is an example of another chemical change. We've also spoken about rust, right? The formation of rust on steel. So now that we've spoken a little bit about this, I think it's important to kind of quiz ourselves whether we actually understood everything, right? So it's just going to be a couple of questions, and then you try to see if you can answer them, right? So the first question there, it says that for each of the following definitions, you have to give one word or term. So they give you a description of something, and you have to provide a one word or a term for this description. So it says a change that can be seen or felt where the particles involved are not broken up in any way. So what type of change do you think that is? Remember we said that we have two types of changes, with chemical or physical. So in a change that you can see that something has happened, you can even feel it. However, there's no breaking up of particles or compounds in any way. Can and if you the answer to that was that it's a type, it's physical change. You are very much correct, because we said that the difference between physical and chemical change is that during physical change there's no new substance that is formed, there's no breaking up of particles in any way. And then the second question, number B, there still have to provide a one word or a term, right? So it says the formation of new substances in a chemical reaction. What type of change do you think that is? And I'm sure you've guessed it, it's chemical. So during a chemical change, we form new substances. And I think this is the last one. C is the reaction where a new product is formed from elements or smaller compounds. A reaction is a type of a reaction where a new product is formed from elements or smaller compounds. What type of reaction do you think is that? And if you guessed it, it's a synthesis reaction. Remember the difference between synthesis and decomposition, right? So now we're moving on to the second question. The second question requires us that for each of the description, state whether it is an example of a physical or chemical change. So they provide you with a description, and you have to mention whether it's a physical or chemical change. So let's say now you mix hot and cold water. Do you think that is an example of a physical or a chemical change? And if, as you've guessed it, it's physical change, because it doesn't, we still have water. It's the cold and the hot water, both of them are water. Even in the end, whatever you will get, maybe you'll get lukewarm water. The water molecule will still be intact, it will not be broken up in any way. Now when milk turns sour, what type of reaction do you think that is? I think that is an interesting one. So it's actually a type of a chemical change, because when the milk turns sour, it's actually you form, I think it forms a type of an acid. I think it's lactic acid. So you start off with something and it ends up being something else, right? And then a car starts to rust. We've spoken a little bit about this. It's a type of chemical change because of this brownish layer on top of your steel that you will observe when the iron has oxidized, and it will form that. It's actually a type of chemical change. Now when your food digests in the stomach, what type of change do you think is that? Remember, the food in your stomach will combine with the acid. I think it's HCl, hydrochloric acid in your stomach, and then your food starts off as something else and it ends up as another. So it's an example of a chemical change. Let's say now you take alcohol, pure alcohol, that's ethanol, and then you rub it on your skin, and what you will observe is that it will disappear. So what type of, is it a physical or a chemical change? Think about it a bit. So it's actually a type of a physical change. And what happens is that the alcohol will actually just evaporate into the air. Hence, it seems as if it has disappeared. When you warm your food in the microwave, do you think that's a type of a physical or is it a chemical change? So you're not actually changing, you're not breaking up any molecules. What you're doing is just exciting the water molecules in your food, and your food will get warm. So it's a type of a physical change. Question 3 here, it says, for each of the following reaction, say whether it is an example of a synthesis or a decomposition reaction. Remember, we differentiated between synthesis and decomposition. During synthesis, you start off with smaller compounds or elements, and then you build up or you create a larger compound. During decomposition, you start off with a bigger molecule or compound, and then you break it apart into smaller compounds or elements, right? So look at this. So they have, I think this is ammonium carbonate, and then at the beginning of reaction, after the reaction has taken place, they have ammonia. There they have carbon dioxide, CO2, and then H2O, they have the water. So what type of reaction do you think this is? Is it synthesis or decomposition? It's a type of a decomposition reaction because you started off with this large compound here, then it was broken up into smaller compounds. You have your ammonia, carbon dioxide, and water. So it's a form of a decomposition reaction. Even when animals die, they decompose. So there's that breaking up of large compounds. Um, So this one here, where you start off with nitrogen plus the hydrogen and you end up with this. Do you think this is a synthesis type of reaction or it's a decomposition type of reaction? And as you have probably guessed it, it is a synthesis because you started off with these small molecules, high nitrogen and hydrogen, and you formed a larger compound, right? Awesome. So you take the last example over here. Um, so the last example over here is calcium carbonate, and then it seems that at the end of the reaction with calcium oxide as well as carbon dioxide. Is it synthesis or decomposition? And as you might have guessed it, it is a decomposition reaction because this calcium carbonate compound was broken up into these smaller compounds, right? You started off with something, you end up with another thing. Okay, so before we end today's lesson, we're just gonna look at, I took an example from a question paper. I took this from an app. There's this app that you can download. I think it's called, I'll leave it in the description where I took this question. So I think it's a good idea to always practice with exam questions or test questions, right? So question 1, they are saying that we have to study the physical and chemical processes that are given below, and then we have to answer the questions that follow. So they've given us 3 changes or chemical reactions. Some of the chemical reactions here are physical, others are chemical. So X, it says that we have H2O, which is a solid, maybe it's ice, and then after the reaction we have H2O, the water, in a gas form, right? Y, you have calcium carbonate, which is a solid, and then after the reaction you have calcium oxide, which is a solid as well, plus the carbon dioxide, which is your gas. It's released. Z is a it's also a chemical reaction. They give you the sentence. It's iron that reacted with oxygen to form iron oxide. And now they will ask us, we have to answer the questions that follow. So the first question is very important for you to understand, to define terms. This is at the lowest level of cognitive level, level 1, which is just your ability to memorize. So you have to memorize this definition. the term physical change, you have to know how to define it, as well as chemical change. This will normally carry about 2 marks in your exam or test, so you have to know it by heart, you have to memorize it. So we'll define physical change as a change that can be seen or felt but does not involve the breakup of the particles in the reaction. And during this physical change, the form may change, but not the identity. It means that there's no new substances that is changed, only the form has changed. What perhaps it looks like has changed, but the substance is still intact. If it's water, it will still be water. It may start off as a liquid and end up as a gas or steam. However, it is still water. You also have to know how to define chemical change. It's very, very important. And in the second question, it says that we have to write down the letter of the process that represents the following. So you're given 3 letters, X, Y, and Z. So now you have to look at the 3 chemical reactions that you are given. Which one, according to you, represents physical change? Is it X? Is it Y? Is it Z? So look at it, take a second to think about it. Which one? And you now know you understand your the definition of physical change. So if you said that letter X represents physical changes, then you are correct, because you start off with a water and then you end up with water, right? The only difference that at the beginning of your reaction it's solid, then something happens and then it forms a gas, but it's still water. The rest of them are chemical reactions, because you started off with a calcium carbonate and then you end up with calcium oxide and carbon dioxide. You started off with iron and oxygen and you end up with iron trioxide, right? Cool. Now let us look at 1.2.2. Which one between this in this reaction represent a decomposition reaction? So we look between Y and Z. Which one do you think is a decomposition reaction? Just remember in the definition that you've already provided of what constitutes a decomposition reaction and what constitutes a synthesis reaction. And if you've said that letter Y represents decomposition reaction, then you are correct, because you started off with this large calcium carbonate molecule, right? Then you end up with, it breaks apart, something happens, it breaks apart into calcium oxide and the gas there that is released is carbon dioxide. And then they say in 1.3, give the name of the physical process stated in question 1.2.1. I don't know, my slide is not allowing me to go back, which is really frustrating me. But I'm sure you've written it. In 1.2.1, we were talking about that water that started off as a solid, remember H2O, and then in the parentheses or the brackets, we had, let me see if I can find a pen. So we had H2O, right? And then in the brackets or the parentheses, oof, it was written that it's a solid. And after the reaction, something happened. It was now still the H2O is a type of physical change, but now it's in a gaseous form, right? And they're asking what type of physical process is stated there. In term, I think in the first term you talked about physical processes. So when something moves, or when a chemical or compound changes from the solid to gas, we call that a sublimation process. Remember, when it moves from being a liquid to being a gas, we say that is evaporation, right? When it moves now from being a solid to being a gas, we call that sublimation. So just revisit your term 1 work and you'll find all of this. And the reverse, when it moves from being a gas, if I'm correct, to now being a solid, is called deposition. Or when it moves from being a gas to being a liquid, that's condensation. So it's very important for you to understand those physical processes. And it's also very important for you to revise your term 1 work. especially in terms now of naming these compounds. It's very important because now in term 3 they're not going to teach you how to name. The assumption is that you already know because you've done the work, right? Okay, let's move on to the next question. The next question is saying that we need to state two properties of a reaction that indicate that a chemical change has taken place. So what would tell you if you were in a lab and you were doing an experiment and you were playing with chemicals, adding things in there, and then things happen? How would you know that a chemical change has taken place? Well, there's a number of ways that you can know. One of the first things that you will note with many, okay, that's highlighted, with many chemical reactions or chemical reactions. So let's say you add a chemical in the lab with another. So both of them, maybe they are colorless in the beginning, and then when you combine them together, all of a sudden you get this yellow color. So normally that's an indication that a chemical change has taken place, right? We're asked to give two, but we'll look at a number of them. Another time you feel a change in temperature. I'm looking for an eraser just to remove this. Yes. Another time you'll feel a change in temperature. So you add a certain chemical to another, and then when you hold, maybe you place them in a beaker or a cup, and when you hold that cup, you feel that it's actually getting warm. Then that's one of the ways that will tell you, that will inform you that a chemical change has taken place, right? Another example is the formation of a gas. Sometimes when you add two liquids together, carbon dioxide will be released. You will see some bubbling in your cup or whatever holder you're using for this chemical reaction. At other times, you form something called a precipitate. So you add two liquids together, and then when you look at the bottom of your cup or beaker, you see some whitish solid substance. Normally, that we call the precipitate, and then you know that will inform you that a chemical change has taken place. This actually brings us to the end of this video tutorial. Hope you learned something. It's very important to understand all of this before we can move on and say now we want to balance chemical equations, which we will do in the next video. Thank you so much for watching.